Inverse variation. What is it? It is a function in the form of y equals k divided by x, where k cannot be equal to 0. Y varies inversely with x. So as x increases, y also increases. And as x decreases, y also decreases. So the constant of proportionality, okay, which is the letter k, alright, so the constant k in y equals k over x is called the constant of proportionality. It also has a special equation, if you notice, and k is equal to x times y. That's how we can find the constant of proportionality. So finding inverse variation from a graph. The graph of the inverse variation is a curve, okay, that gets close to but never actually touches the x-axis or the y-axis. Okay? Never actually touches either one of them, but it gets close to it. Okay? Notice it gets close to it, but it does not ever touch. Okay? And notice these are curves. Alright? So if you see any graph that looks like this, that have curves, where they do not touch the x-axis or the y-axis, that is considered an inverse graph. Finding inverse variation from a table. Remember what we said, that k is equal to x times y. So if I have a table, we can pretty much figure out what the k value is. If they all have the same k value, then it is inverse variation. So let's see what we get. What I'm doing here is I'm going to take each x and I'm going to multiply it with the y, because that's how I can find my k value, because it's x times y. So 2 times 5 gives me 10. 4 times 2.5 is also 10. 8 times 1.25 is 10. And 16 times 0.625 is also 10. So because all of them equal to 10, and they're all the same, the k value is 10, so this does represent an inverse variation. Notice if one of the numbers would have been different here, then this would not have been inverse, but because they're all equal to the same value, that means that it is an inverse variation. Finding inverse variation from an equation. So when the equation is solved for y, okay, which is essentially what we want, okay, inverse variation will be in this form, y equals k divided by x. Okay, so the following equations are in this proper form of y equals k divided by x, so they represent inverse variation. So what we're going to quickly do is just identify what's my k value then. So what does our k value equal? So let's see, for the first one I know it's y equals k divided by x, so the k is 3. Second one, I have y equals 12 divided by x. 12 is my k. The next one, y equals 150 divided by x. And remember, it's y equals k divided by x, so my k is 150. Next one, same concept, y equals negative 6 divided by x. And we know the equation is k divided by x, so therefore my k is negative 6. And notice the last one looks a little different. Have 9 times 1 divided by x. Well, if we were to break that down and multiply it, we would end up with y equals 9 divided by x, which is still in inverse variation form of y equals k divided by x. So here our k value would equal 9. If it is not solved for y, you, guess what, lucky you, have to solve for y. And remember, we use 3 wonderful letters to help guide us, and that's B, C, D. So, for this first example, 6x times y equals 12. First thing I'm going to do is box my y variable, because that's what I'm solving for. Is there anything next to my box to cancel? No, so I don't have that step, so I go straight to the last step, which is to divide. And what am I dividing by? The 6x, because that's what's inside my box. So notice the 6 and the x cancel out, and you get y equals, well, 12 divided by 6x, well, you can only really divide those numbers, and 12 divided by 6 gives you 2 over, the x stays in the bottom of the fraction, so we get y equals 2 divided by x. Notice, this is in inverse form, y equals k divided by x, so k is equal to 2. There's our answer. Let's try one more example. Same concept, 3 letters B, C, D. First I box my variable, which is the x, y. Is there anything next to it to cancel? No. So we go on to the next step, which is D for divide. The only thing I have to divide here is the letter x, because that's what I got to get rid of. So we end up with y equals, you can't simplify 15 divided by x, so you keep it. Notice it's an inverse form, y equals k divided by x, so we get that k equals 15. Finding k from a word problem with given the x and the y. So suppose that y varies inversely, okay, with x. When x equals 5 and y equals 9, how do we find k? Well, step 1 is we know that because y varies inversely with x, that k is equal to x times y. Okay, we talked about that on a few of the previous slides. Okay, so all I have to do then is substitute 5 for x and 9 for y, because that's what they told me that I know. And then we can figure out what k is. So if I have k equals x times y, k equals x is 5 and y is 9. Well, I can actually break that down further, because 5 times 9 is 45. So k equals 45. Finding x or y from a word problem when you're given the k value instead. So suppose that y varies inversely with x and k equals 7. What is y when x equals 2? So two key things that we know here, that k is equal to 7 and x equals 2. So step 1, we know that because y varies inversely with x, that y equals k divided by x. So all we have to do is substitute 2 for the x and 7 for k. So we end up with y equals, k is on top, and that's the number 7, divided by x, which is 2. Can you reduce 7 divided by 2? Nope, you can't. So that is the answer. Y is equal to 7 divided by 2. Next one. Suppose that y varies inversely with x and k equals 20. What is x when y equals 4? Now, step 1, we know that because y varies inversely with x, and I'm going to change this one up a little bit. We're going to say that because we know that k equals x times y. So we're going to substitute 20 for k and 4 for y, and then we're going to just simply solve for x. So let's see what we get. 20, because that's where k is, equals x times 4, because that's what y is. Well, solve for x. Remember, 3 simple steps, B, C, D. First, you box your variable. Notice, is there anything next to it to cancel? Nope. So we go straight to the last step, which is to divide. And I'm going to divide by 4, because that's the number inside the box. And we get 20 divided by 4, which does reduce to 5. So x equals 5. Write an equation for inverse variation. Step 1, find out what k is. And then step 2, plug k back into our inverse equation, which is y equals k divided by x. So let's write an equation for a variation for y equals 30 when x equals 5. So first of all, we have to figure out what is k. Well, to find out what k is, all we have to do is know that it's x times y. So in other words, k equals, we have those two values. X is 5, y is 30. So that tells me that k is equal to 5 times 30, which is 150. Now remember, we're writing an equation, an inverse equation, so it's going to be that y equals k, which is 150, divided by x. So that would be our final answer for writing the equation. Second one, write an equation for variation of variation for y equals 0.4 when x equals 0.7, where y varies inversely as x. So, same concept. First thing we have to do is figure out what is k. And we know if it's inverse, which it says it right there, that k is equal to x times y. So, we can see that k is going to be equal to 0.7x times 0.4, which is our y. Well, what does that give us? That k equals 0.28. So if we know that, then we know that our equation is going to be y equals k divided by x. Or in other words, y equals 0.28 divided by x. And that would be our final answer. Finally, last one here. Find an equation that relates x and y inversely and y equals 10 when x equals 5. So notice they changed the wording of the question, but they're still asking for the exact same concept. In order to do this, the first thing I have to know to write the equation is what is my k value. And we know that our k value is x times y. So we can agree that we're going to have k equals, what is the x and what is the y that they gave us? X is 5, y is 10. So k equals 5 times 10, which is 50. Now we can't stop there. That's just the constant of proportionality, which is what the letter k stands for, reminder. So the end answer is that y equals k, which is 50, divided by x. That would be the equation in inverse form. Alright, so now we're going to use something called the product rule. And what the product rule states is that we have x times y equals x times y. So it's basically meaning that we're given 3 pieces of information. So it takes 4 people 10 hours to resurface a stretch of road. The number of people P, that's our y, it takes varies inversely with the time, which is our x. How long will it take 8 people to do the same job? Notice we get 3 pieces of information here. So, the first part I have 4 people, 10 hours. Second part, all I know is I have 8 people, and they want us to know how many hours. So first thing I do is I take and set up our product rule, x times y equals x times y. Well, in the first part, I have 4 times 10, or as I should say, we'd have 10 times 4 equals, here I know that the y value is 8, and I don't know what the x value is. So 10 times 4 gives you 40 equals 8x. Solve for y. Remember BCD. Notice the only step I have to do is divide by 8. And we get that x equals 5. So the answer is that it would take 8 people 5 hours. Next problem. The volume V of a gas varies inversely as the pressure P on it. If the volume is 300 centimeters cubed under a pressure of 48 kilograms over centimeter squared, what is the volume of pressure of 25 kilograms over centimeter squared? Alright, so again, let's break this down. Volume and pressure are the 2 things that we have. Volume is going to be representative of our y value. Pressure is going to represent our x. The reason why it's like that is because it's always that your y varies inversely with your x. Okay? Pretty simple. So let's write our product rule. X times y equals x times y. Now the first x and y they give us is the 300 and the 48. Okay, so let's see. X is first, and x is my pressure, and the pressure is the 48. Times the volume, which is 300, and that should equal, now in the second part they gave us one more piece of information, and that's just the pressure. So we don't know what the volume is. So that's 25 times y. Well, 48 times 300 gives you 14,400 equal to 25y. BCD, box, cancel, divide. Notice I don't need to box because there's nothing next to it to cancel, so all I have to do is divide both sides by 25. And we get that our y is equal to 576. So you have 576 centimeters cubed as the volume. Alright, check what you remember. So it'd be awesome if you guys would just pause the video right now and see if you can answer these questions yourself. It's real simple. The first part here is which graphs show inverse variation based on the picture. Okay. Second part here, which table shows inverse. And then down here, which equation shows inverse? If it does, what is the k, which is a constant of proportionality? So remember, you can always just pause this and go back, look through your notes, and refer to each part, looking at graphs, looking at tables, and then looking at the equations to find the answers. So I'm going to go ahead and work them all out, and then hopefully you guys paused it and you worked them out on your own first. Alright, so which graphs show inverse? Okay, clearly the first one does show inverse because notice there are curves and they do not touch the x-axis or the y-axis, both of those curves. Okay, the second one, notice it is not inverse, it's actually linear. Why is it linear? Because that is a straight line. Now looking at the table, which table shows inverse variation? Remember, inverse variation we use x times y. So that's what I did here. I did x times y and figured out what would be the k value. In order for this to be inverse, they all have to be the same. Notice here I get 15, but 12 times 1 gives me 12. So because they're not all the same, this is not inverse. Now in the second table, when I did this and I did x times y to find the k value, they all gave me the same answer of 12. So it is inverse, and you can also tell me that k equals 12. Now for the last part, which equation shows inverse variation? And if it does, what is the k value? Notice the first one, I have 3y equals 6x. What I have to do here is I have to divide both sides by 3, which is what I did. And when I reduce or simplify it, we get y equals 2x. Notice this is not an inverse because it's supposed to be y equals k divided by x. Second one, notice I had a 5xy equals 10. Box my variable. I notice that there's a 5x that I have to divide both sides by. When I reduce, y equals, well, 10 divided by 5 gave me 2, so that goes on the numerator. X is in the bottom of the fraction, so it stays on the bottom. So notice it does give me y equals kx. So yes, it is inverse, and k equals 2. Now the second one is kind of flip-flopped, right? Y equals x divided by 2, which automatically is no, because the k value is in the wrong spot, or in the wrong location. Okay? So notice I actually took the time to rewrite it. I'd put a 1 in front of that x, and it actually is a y equals 1/2 x. So that clearly shows you that that's not inverse. The next one, notice it's set up as two fractions, look like proportions, so that's why I went ahead and did cross multiplication. And when I do that, I got y times x equals 4 times 2, which is 8. Well, if I box my variable here, I notice that there's an x with it that I need to get rid of by dividing. And then I end up with y equals 8 divided by x. Notice it's in inverse form, y equals k divided by x, so yes, and k is 8. The last one, very simple. If I box that xy, I notice that there's an x with it, so I had to divide both sides by x, and my final answer was y equals 9 divided by x. It's in inverse form, so yes, it is inverse, and k equals 9. Hopefully you guys don't find this too difficult to do. Just key equations for you to know, and that's y equals k divided by x, and that k equals x times y.